I am Nicolaus Copernicus, a canon from Frauenburg who has spent a lifetime gazing at the heavens.
The wandering paths of the planets, with their loops and circles, seemed far too clumsy for a divine creator.
For years, I kept this new arrangement of the heavens to myself, fearing the scorn of the world. My book was published only as I lay dying, a new vision of the cosmos for future generations. My name is Galileo Galilei, and I have always believed the book of nature is written in mathematics. I fashioned my own telescope and was the first man to see the mountains and craters upon the moon. I discovered 4 new stars orbiting Jupiter, proving that not everything in the cosmos revolves around us. For saying the Earth circles the sun, as Copernicus wrote, the Holy Inquisition has called me a heretic. They can silence my voice and confine me to this house, but still, the Earth itself continues to move.
I am Johannes Kepler, a mathematician searching for the divine harmony hidden within the celestial clockwork.
For years, I wrestled with the orbit of Mars, but its path refused to conform to a perfect circle.
The truth, I finally realized, was that planets travel not in circles, but in elegant, stretched ellipses.
And I discovered that a planet moves faster as it nears the sun and slower when it is far away. These are the laws of the heavens, the celestial music I was always so determined to finally hear. I am Isaac Newton, a man trying to understand the intricate machinery of God's grand universe. People speak of a falling apple, but my universal laws of motion were born from decades of observation. Light is not merely color, but the key to understanding the universe itself. As you can see from the diagrams, the celestial spheres align precisely with my predictions. The heavens do not lie. These observations confirm that the Earth cannot be the center of the cosmos. I am Antoine Lavoisier, and I believe that chemistry must become a true science of precise measurement. Through careful weighing, I proved that the old theory of phlogiston was nothing more than a chemical ghost. I gave the name oxygen to that vital air which is the very essence of combustion and of life itself. My greatest law is simple. In any reaction, matter is never created or destroyed. It merely changes its form. For all my work, the Republic has no need of scientists. My head will soon fall to the guillotine's blade. My name is Michael Faraday, the son of a blacksmith, who learned science not from school but from books.
I have always been fascinated by the invisible forces that connect the worlds of electricity and magnetism.
I discovered that by simply moving a magnet within a coil of wire, I could generate an electric current. Then I reversed the wonder, showing that an electric current could in turn make that very wire spin with motion. I may lack the mathematics, but I can see the invisible fields of force connecting everything in our world.
My name is Charles Darwin, a simple naturalist who spent 5 years sailing the world on the Beagle.
On those distant shores, I saw how every living creature was so perfectly adapted to its unique place. I came to believe that nature selects for survival, a constant struggle for existence shaping all life. From this simple beginning, endless forms most beautiful and wonderful have been and are being evolved. For 20 years, I kept my theory private, fearing the great storm of outrage I knew it would unleash.
I am James Clerk Maxwell, and I have always believed that mathematics is the purest language of nature.
I took the brilliant experimental work of Faraday and translated his invisible force fields into precise equations.
My calculations predicted that waves in this new electromagnetic field would travel at a very specific speed.
To my utter astonishment, that number was the exact measured speed of light. It could not be a coincidence. And so I proved that light itself is just a ripple, an electromagnetic wave traveling through the universe.
I am Marie Skłodowska-Curie, a scientist who dedicated my life to the study of the unseen.
My husband Pierre and I investigated strange energy rays, a phenomenon I named radioactivity. In our humble shed, we toiled for years to isolate two new elements, polonium and radium. I became the first woman to win the Nobel Prize, and then the first person to win it twice.
My work helped create new medical treatments, though it was my own discoveries that eventually ended me.
I am Albert Einstein, a man who has simply never outgrown his childlike curiosity about the world. I imagined chasing a beam of light, and it revealed to me that time itself can stretch and shrink. From this, I realized that even a tiny speck of matter contains an immense and truly frightening energy. I later saw that massive objects don't pull the planets, but warp the very fabric of space-time itself. And yet, for all I've learned, I still refuse to believe that God plays dice with the universe.
I was shooting tiny alpha particles through gold foil, expecting them all to pass straight through.
I'm a simple colonial lad from the edge of the empire who has always enjoyed playing with invisible things.
But some bounced back, as if I had fired a great cannonball at a piece of tissue paper.
This meant the atom was mostly empty space, with a tiny, dense, positive nucleus at its heart.
Later, I used those same particles to chip a piece off a nitrogen atom, becoming the world's first alchemist.
I am a physical chemist who found both beauty and profound truth in the unseen structures of all matter. Powerful X-rays, I sought to photograph the precise arrangements of atoms, to reveal what others merely imagined. My critical image of the vital molecule was the clearest yet, showing its cross shape and an incredible twisted form. It was a challenging journey, my efforts often misunderstood, my contributions sometimes overlooked by other researchers. But the undeniable evidence was clear in every diffraction pattern. The secret of life lay within those precise angles.
I'm a mathematician who has always believed that any great problem is just a puzzle waiting for a logical solution.
In the Great War, my team designed a machine to outthink our enemies and break their most secret codes.
I theorized a single machine that could perform any conceivable task simply by reading a tape of coded instructions.
The question that truly consumed me was whether a machine's replies could ever become indistinguishable from a human's.
But for all the wartime secrets I kept, my own country punished me for the one I could not hide.
I'm a chemist who learned to see the beautiful architecture of life's most essential and complex molecules. By shining focused beams of X-rays through crystals, I could patiently map the shadows cast by atoms. My team worked for years to finally reveal the intricate, cage-like structure of that life-saving mold.
But the greatest challenge was the hormone for diabetes, a protein so complex it took decades to map. These are not just beautiful patterns. They are the very keys to fighting some of humanity's worst diseases.
I am a computer scientist, driven by a deep desire to connect disparate pieces of information seamlessly.
At CERN, all our data was trapped on separate computers. Finding anything was a frustrating maze of dead ends. So I designed a universal system using linked references to connect various documents, wherever they might reside.
I then built the initial tools and of the viewing program and the information host, and have needed to bring this connected system to life. This new space was meant for everyone, and I gave the idea away for free, as a tool to empower all of humanity.
I've always been a girl who was simply in love with counting and the certainty of numbers. At the research center, they called us the human computers, tasked with charting the paths for our first flights to the stars. The astronaut famously said he wouldn't fly until the girl personally double-checked the new computer's numbers. My calculations helped chart the critical rendezvous path that would bring our lunar explorers safely back home. My calculations were not just numbers on a page. They were the invisible lines that guided our explorers home. I am a naval officer by rank, but I have always been more of a pirate in the complex world of computing. My team once found a real moth stuck in a relay, and so we started calling our fixes debugging the system. My invention was a bridge, a program that let us speak to the machine in our language, not just its own. From that concept, we developed a new language that allowed everyday business people to write their own programs. I always taught my crews that the most dangerous phrase is simply, "We have always done it this way." I am a countess and a student of mathematics, one who seeks the poetry hidden within the science of numbers.
A great inventor showed me his analytical engine, a machine of brass gears designed not just to calculate, but to reason.
In my notes, I wrote a sequence of operations for his machine, a way to weave patterns with algebra, like a loom with thread. I realized that this machine could do more than solve sums. One day, it might even be able to compose music. While the engine was his magnificent creation, I believe I was the first to see its true, creative soul.
I'm a mathematician who has always believed that all things can be understood through the universal language of logic.
I took the strange new theories of the quantum world and gave them a rigorous mathematical framework to stand on.
Even in a card game or a global conflict, I saw the cold, hard mathematics of strategy and the optimal move.
My key insight was that a machine's instructions and its data should be stored together in its memory.
From weapons of immense power to thinking machines, I've seen how one logical idea can reshape our world.